For our binomial probability distribution, we are discussing the 5 flights daily from Pittsburgh via U.S. Airways into Bradford, Pennsylvania Regional Airport. Suppose the probability that any flight arrives late is 0.20. What is the probability that none of the flights are late today? What is the average number of late flights? And what is the variance of the number of late flights? Well, I've already laid out a few of the things that you need here, and I did include the formulas so that you can kind of see what each of these items mean. Down here is an example of the function that Excel uses to do a binomial distribution, and this is a translation to the terms that Excel uses compared to our book. So what are we doing first? We need to get our values to do the distribution. So our n happens to be the number of flights that we're doing daily, and that's 5. Our pi, or our probability that any flight arrives late, is given to us, and that's 0.20. So now we can go in and create our first probability. Now for the question, it's only asking for none. What's the probability of none or 0 of the flights are late today? So we could just do the one calculation, but for the purpose of our explanation and for the purpose of learning the probability distribution a little bit better, we're going to go ahead and fill out the whole thing. And there you have it. You see, if you just start typing in equals binom, it'll pop up, and you can go ahead and punch in your information directly right here if you prefer, but we're going to go ahead and pop up the function arguments list so that you can see it. In each of the cells, it'll explain a little bit about what that number means, or what that value is supposed to mean. So we're using our formula translation here, or our Excel to book translation. We'll see that number underscore s is actually our x value, which is our success rate, or our number of successes, and for the first one we want 0. But what we're going to do is we're going to reference it to this cell so that when we copy the formula, it'll work for the subsequent x values, or success values. The number of trials that we have equates to our n. Our n is 5 flights, and the probability is given to us. That's pretty straightforward, but the probability underscore s in Excel means pi for us, and that's given as this 0.20. Now the cumulative is something that we haven't seen in here, in the textbook that is. But what this is doing is it's offering us the opportunity to do a cumulative probability distribution, and if we were to type in yes, we get a true value, which means yes, we do want it to be cumulative. And we do not want it to be cumulative here for our probability distribution, but we will want it to be cumulative when we do the cumulative probability distribution. So for now we just type in a 0, we hit OK, and we have our value of 0.32768. We can copy that formula down. We get all of our subsequent probability x, or successes, for each of the values. Now we can go over and we can start our cumulative probability distribution values. And again, we pull up the binomial, as long as we spell it correctly. We'll hit the function, and the numbers are going to be the same, so we're going to use our success. The trials are the same, the probability is the same. The difference here is now we want it to be cumulative, so we hit OK and we have the same value. Well, that's because we're at 0. But once we go ahead and start accumulating all of the values, it runs right up to 1, just the way it's supposed to. So for the answer to number 1, what is the probability that none of the flights are late today? It's 0.32768. If we wanted to know what's the probability that 4 are late today, we just go to the 4 row in our probability distribution. To calculate the mean, we have the formula down here, which is n times pi. So we just type in equals n times pi. We could just type in equals 5 times 0.2, and we hit enter and we get 1. So the average number of late flights is 1. And what is the probability that none of the flights are late today? What is the variance of the number of late flights? That's equal to our n times pi times 1 minus pi. So we can type in our n times pi times 1 minus pi, and we get an error because I forgot to close out the parentheses, and we get a 0.80, and our variance is 0.80, and to get the standard deviation we just take the square root of our variance, and we get a 0.8944 for the standard deviation. I didn't ask that question in here, but we threw it in because it's a straightforward calculation to do. Now we can also do this in Megastat. And we go into Megastat, go to probability, discrete probability distributions, and I already have the values in here, but it's much more straightforward even than the Excel function calculation. You just put in the number of trials, our n, which is 5, and you'll notice that in Megastat they use p instead of the Greek symbol for pi, but it's the same value. And we'll leave the graph in just so we can look at it. We'll hit OK. Let it do its thing. And we have our probability distribution right here. You'll notice the numbers are the same: 0.0032 for 5, 0.32768 for 0, 0.32768 for 0, and 0.00032 for 5. Our cumulative probability, our expected value, which equates to the mean, is 1, just as we calculated. Our variance is 0.8, and our standard deviation is 0.894. We took it out 1 decimal place further, and that's the binomial probability distribution.